Welcome to the Virtual High School. In this lesson, we are going to be taking a look at some of the theory behind operations with fractions. Now, when adding or subtracting fractions, a common denominator must be found before the fractions can be combined. This is done by finding the lowest common multiple of the integers in the denominators. Now, let's just stop there for a second and go take a look at an example. Let's say we've got a half plus a third. Could have been a half minus a third as well. It wouldn't have made a difference to the technique. What they're saying there is we find the lowest common multiple of the integers in the denominators. Now the integers in the denominators would be below the line, the 2 and the 3. Lowest common multiple of 2 and 3 would be 6. Each fraction must then be re-expressed as an equivalent fraction with this new denominator, which means we must multiply the 2 by 3 to make that 2 grow into 6, but then we'll multiply that 1 by 3 as well. So we'll get the half to become 3 over 6, which is an equivalent fraction to a half, because that's exactly what they meant. We re-express the half as an equivalent fraction, namely 3 over 6. And we'll do the same with the third. We'll multiply by 2 there and by 2 there to get 2 over 6, which is again an equivalent fraction of 1 over 3. Then they say, once done, we add or subtract the new numerators, leaving the denominator the same as it was once the common denominator was found. So what they're saying is, now since we have a plus there, we still have the plus there, we only add the numerators. 3 plus 2 is 5. We leave the denominators the same. We don't add them together as well. So we've got 5 over 6. So let's just read that sentence again. Once done, so after we've found the equivalent fractions, we add or subtract the new numerators, which we've done. We added the 2 and the 3 together to give us 5, leaving the denominator the same as it was once the common denominator was found. So we don't leave the denominators the original 2 or the original 3, we leave it as 6, because that was the step after the common denominator was found. When multiplying fractions, we simply multiply the numerators and the denominators. Let's look at an example for that as well. A half multiplied by a third. We simply multiply the numerators. 1 times 1 is 1. And we multiply the denominators. 2 times 3 is 6. So the answer of a half multiplied by a third is equal to a 6. Very simple operation there. When dividing fractions, we invert the second fraction and multiply. Now what do they mean by that? If we divide fractions, so we've got a half divided by a third, which means, according to that rule, we invert the third, so that will become 3 over 1. We've still got the half. They didn't say anything about the half, so we leave the half as is, and then multiply. So the division sign there has now become a multiply, and we're back to multiplication of fractions. Multiply the numerators, 1 times 3, and multiply the denominators, 2 times 1, which will give us 3 over 2. Now after all operations are performed, we then look to reduce or simplify the resulting fraction. So now they're saying the 1 over 6 up there, we can't do anything about that. It is in the most simplified form. But for the second one, after we've multiplied the numerator and the denominator, we now get 3 over 2, which we can say 2 goes into 3 once, and what remains is 1 over 2. So 3 over 2 is the same as saying 1.5. So we've simplified or reduced the fraction after we've multiplied. Now in some cases you might get the opportunity to cancel like that or like that. Across, bottom to top, you could maybe cancel if that's going to help you to reduce the multiplication, the complexity of the multiplication. You can actually start cancelling out common factors before you multiply the numerators and the denominators, but let yourself be guided by the question in that regard. Then be sure to change mixed fractions to improper fractions before the above rules are applied. So in other words, if you are given 1.5 multiplied, for instance, by 4 and a third, first of all, make those two mixed numbers into improper fractions by multiplying the 2 and the 1 there, and then adding that 1. So 2 times 1 is 2, 2 plus 1 gives me 3 over 2, and we do the same for 4 and a third. 4 times 3 is 12, plus 1 gives me 13 over 3, and now only do I see if I can multiply above and below the line. But just a case in point, at this moment we could actually cancel that 3, goes into itself once, and into that 3 once, and we'll multiply the 1 and the 13 and the 2 and the 1, and we'll get 13 over 2, which is an improper fraction that could be taken back to a mixed number by saying 2 goes into 13 6 times, and what remains is 1 over 2. When the fractions are given as decimals, we add or subtract by first lining up the decimal place. The decimal place serves to keep all values aligned in their place values. So if you know how to do vertical subtraction or addition, you simply do exactly the same when you've got decimal fractions. Just remember to align them with the comma as the reference point. That's all it is, because the comma keeps the values aligned in their place values. So that's very important. Just keep them aligned, and then do your normal carrying over or borrowing as you would have done in normal numbers that you added or subtracted vertically. Just keep the comma in place. When multiplying decimals, we are working with decimals at this moment. When multiplying decimals, we multiply the values as if there was no decimal, and then move the decimal from the ones column to its proper spot in the solution by moving one place value for every decimal place in the two numbers combined. What do they mean by that? If, for instance, we have 0.02 multiplied by 0.2, for instance, what we do is we multiply them as if we did not have any commas. So we'll simply ignore all the zeros to the left, and we'll treat any zeros to the right, if there were any, as if it was a place value. So now we'll have 2 times by 2, which gives me 4. Then we count the number of decimal places in the original question. So it's 1, 2, 3 decimal places in the original question. Therefore we need to have 3 decimal places in our answer. We've got the 4, which is already one of the 3. We fill up with zeros to the left, and then we put the comma. So 0.02 times by 0.2 will give us an answer of 0.004. And that's all they meant by that. Let's just read through it again so that you understand. When multiplying, we multiply the values as if there was no decimal. Like we said, just multiply the 2 and the 2 together, and then move the decimal from the ones column to its proper spot in the solution by moving one place value for every decimal place in the two numbers combined. In other words, as they were originally. Add the number of decimal places originally, and that will then tell you how many decimal places your answer need to have. When dividing, we move the decimal in the value in the denominator as many places as to create a whole number. So what they mean by that is, let's say for instance we have 0.2 divided by 0.04, for instance. What we'll do is we'll do the normal long division with the division bracket. We've got the 0.2 there divided by 0.04 outside, and then we'll move that comma 2 places so that the number outside the division bracket will then become just plainly 4. But since we moved the comma 2 places, we need to do the same inside the bracket. So we'll move it 2 places, which means we need to fill up with a 0 there at least, so that the comma stands there. So 0.2 has now become 20, and then it's a simple matter of dividing 4 into 20, and whatever your answer is, that is the answer of the original division. You don't have to move the comma at all. You can leave it as is. Just remember to move the comma beforehand, before you start dividing. So just to complete that sentence then, let's read it again. For each place value moved in this value, we move the decimal the same number of places in the numerator. So they're just saying we moved it by 2 places there to get a whole number outside the division bracket, so we need to move the comma 2 places inside as well. That's all they mean. We then set up the division and place the decimal in the correct place in the division bracket, meaning the decimal would now be there or there. Remember, in your final answer it would be there as well. Exactly on top of that you'll have your comma, your decimal comma. Thank you for using the Virtual High School.